Solving rational equations. The central question is, what are the steps for solving a rational equation? And what are extraneous solutions? What are you supposed to do with these essential questions we write every day? That is summary. Okay, there's a few people who wrote summaries on their notes when I checked your binders. I need more of you to do it because it's a big chunk of your binder check. So it's a lot easier to do the summary the day of instead of waiting till the binder check and trying to do 10 summaries all at once. Okay, so please do them when you finish the notes and go home. Okay, reminder of what a rational is. We have rational numbers versus irrational. What's an example of an irrational number? So pi, right? 3.14, 15926, dot, dot, dot. Okay? The reason pi is irrational is because it goes on forever. There is no pattern. Girls, did you please stop that? And it can be made into a fraction. Or, excuse me, cannot be made into a fraction. That's irrational. Rational is the opposite. Anything that's rational can be made into a fraction because repeating decimals can be written as fractions, terminating decimals can be written as fractions, integers can be written as fractions. Okay, so our rationals we've been working with the past 2 days, remember the word rational means be written as a fraction. What does equation mean? Yeah? You can solve the equation. Okay, what does an equation have that an expression does not have? So they both have numbers. Equal sign. Equal sign, thank you. Okay, so you have to have an equal sign in order to solve, like you said, otherwise it's called simplifying. Okay, so a rational expression, or a rational equation, excuse me, rational equation contains at least one rational expression. Contains at least one rational, so another fraction, expression. Okay, and this rational expression needs to involve the variable. So if there's just a fraction 1/3, that wouldn't make it a rational equation automatically. Okay, for our first example today, we're going to solve the following. Just have the notes out. Example 1. X over x minus 3. Is this rational? Is it a fraction, guys? Yeah, so it's rational. Okay? And it has a variable. So we're good. Plus x over x plus 3 equals 2 over x squared minus 9. Okay, it's an equation because it has an equal sign. So when we're solving, we're trying to find the value of x that would make it equal. Okay, what's the first thing you should put in all three of these fractions? Thank you, that should be a habit. If you see a binomial, you should stick parentheses in. Okay, just like we did on our startup, we come back here to that one. Okay, number 2, when we're adding fractions, what do we have to have in order to add fractions? Common denominator. And for 9 and 5, how did we determine our common denominator? We just multiply them together. That's an easy way to get a common denominator. It's not always the most simplest form, but it will give you a common denominator. Okay, so let's look at our denominators. We have x minus 3, x plus 3. Do these match?
No.
Nope, so they're not common. And x squared minus 9 doesn't match either. But x squared minus 9 is a quadratic. So for our steps, write a bunch of steps, say about 4, I believe. If there's anything that's a quadratic, where like you have a trinomial, that's a quadratic, we want to factor it first to see if it would match maybe x minus 3 or x plus 3. Okay, so I actually claim this is a trinomial. I'm going to erase this stuff and write it in black so you don't have to write it. X squared minus 9. How many x's are in the middle between x squared and minus 9? 0. Okay, so can you think of two numbers that multiply to negative 9 and add to 0? Yep, 3 and negative 3. Okay, so for step 1, we're going to rewrite it with the factors. Because it just so happens that those factors match the other denominators. How do I write the factors showing 3 and negative 3? How do I write them as factors? X minus 3 and x plus 3. Good. Okay. Now, other way. Now, this one has a match for both the other denominators. Okay, so what would our common denominator be? It's going to be this one, right? Take the two different denominators and multiply them together. It's the same as that one, right? All right, so if you wrote this kind of squishy, you might need to write it out again. It's spreading it out because we're going to have to multiply all the top numerators by two binomials. So if you wrote it really squishy, you need to write it again so that you have room to work with. So I'm actually going to scoot this one over, or just erase like I'm doing and scoot it over, so that you have a little bit of room to work with. Otherwise, it's going to be really squishy. Oops, I should be writing the factors. X plus 3, x minus 3. Okay, so on our list of steps, step 2 is to multiply all numerators. We're only going to multiply the numerators by the LCD. What does LCD stand for?
Least common denominator.
Okay, least common denominator. The reason we multiply by numerators is because most of us don't like fractions. Who doesn't like fractions?
I don't like
Okay, that's honest. I don't like math. Okay? Most of us either don't like fractions or make lots of mistakes with fractions. So if we can get rid of the denominators, that would be way better. So by multiplying in the numerator, we'll be able to get rid of the fractions. Okay? But we're going to have to multiply every numerator with our least common denominator. So this numerator right here, we're multiplying by x plus 3 and x minus 3. Notice I'm writing it in the numerator. Just like in our startup on number 1. In our startup on number 1, when we times by this 3 right here, we times in the numerator. Why did we times in the numerator?
Cancel.
So there'd be a cancel. That's exactly what we want here. Okay, same idea. Okay, now we need to times this numerator by both of them. X plus 3, x minus 3. And we need to times the 2 by x plus 3, x minus 3. So now you can see why you kind of need a room to write. Okay, let's go look for those cancels. Just like the startup problem, there's going to be a cancel when you multiply the numerator. This x minus 3 would cancel with what? The top x minus 3, leaving x plus 3 times x. Okay, plus whatever's left in the second fraction. Okay, newy, what would cancel out in the second fraction? Just positive 3? Yeah, this should be the binomial x plus 3, right?
Yeah.
And x plus 3. Leaving x times x minus 3 equals, now this one's really nice. What happens on the third fraction. Except for 2. Everything has except for 2. And look, all fractions are gone, which is wonderful because most of us struggle. Even I struggle with fractions sometimes. Okay, step 3, of course we were asked to solve, so we're going to distribute, because I get to see some distribution, and then solve for x. When you distribute, it's very important that you always distribute to the left term first. Because if there's a subtraction, you're going to have the wrong signs if you don't distribute to the left term first. Okay, so what's x times x? X squared. And then x times 3 plus 3x. Plus, because that's what comes next, now we have to distribute here. Okay, Chimps, what would we get there? X times x is, and then x times negative 3 equals 2. Alright, what would we do to solve for x now? Good, like terms. We have like terms here, here, and then that 2 is by itself. Right, because we have x squared, so they're like terms, we have x's, which are like terms, and then we have a constant number 2. Okay, so when you write it out, it should be in descending power, in standard form. Okay, m, what's the highest power? The x squared, so let's add them up. And how many x squareds do we have total? Okay, so it'll be 2x squared. And then comes x to the first power. Aiden, how many x to the first powers are there?
6.
Sure?
0.
0, because 3 minus 3 is 0. Those cancel. Equals 2. Okay? Go through and solve for x, please. Turn to your neighbor when you have the answer for x and tell them what you got. Solve for x. Those are your notes for today? What? Are those your notes for today?
Yeah,
I have extra paper if you need paper. Okay. Do you tell your neighbor what the answer is? All right. Jaden, how did you solve for x? Could you tell me how you would if you had? Solving means get x by itself, right? So how do we move the big 2? Well, it's currently being multiplied. What's the inverse operation? What's inverse of multiplying? Dividing. So we divide both sides by 2. And we get x squared equals 1. How do we get rid of the square? Square root. Okay, so what's the answer? Ah, there we go, Eric. Say that louder. Plus or minus 1. Remember, square roots have 2 answers? Good job, Eric. Plus or minus 1. All right, so I mentioned this. Whoops. I mentioned this word in the essential. Why is that not doing what it wants? There we go. Is it? It's being weird. Okay, I mentioned this word in the essential question called extraneous solutions. Okay, if you are given like a story problem and it has extraneous information, that would be a story problem that gives you extra information you don't need to throw you off. Right? Extra information that's not required, that you don't need to know in order to solve the problem. That's called extraneous information. Extraneous solutions is an extra solution that's not required because sometimes when you manipulate the problem, which we did by multiplying all the numerators by our LCD, right? When we manipulate the problem, it could create an extraneous solution, which would be one of these answers might not be an actual solution for the original unmanipulated equation. So how could you tell if both the answers actually work? What? Plug it back in. Great, that's our fourth step and final step. Is we need to check your answers by plugging into the original equation. We need to check our answers by plugging into the original equation. Okay, again, the original equation, since it's up top, I'll just rewrite it really quick, was this. Okay, so if we wanted to check first positive one, how would we figure out if positive one works? What does it mean to check? Plugging it in where? Into the x's. Good. So all the x's we're going to plug in. 1 over 1 minus 3 plus 1 over 1 plus 3 equals 2 over. Now when you're squaring, good practice would be to put parentheses. In case the number we're squaring is actually negative, it has to be in parentheses, so we square them to sign. Okay? So, let's simplify. In this denominator, what is 1 minus 3? Negative 2. So that would be the same as negative 1/2, because it's a negative 2. What's the sign, or what's the sum here? 1 plus 3, so 1/4, equals 2 divided by, what's 1 squared? 1. Minus 9, negative 8. All right. As we've already talked about, most of us aren't so great with fractions, and decimals make a little more sense in our heads. Does anyone know the decimal for negative 1/2? Good, that's one you should have memorized, so I'm glad you guys know that. What's the decimal for 1/4? Good. All right, here's a trick. Who knows the decimal for negative 2/8? Negative 2/8 is the same as which fraction? Negative 1/4. So. Okay, so are these sides actually equal? Negative 0.5, which is the same as negative 0.50, plus 0.25, is that equal to negative 0.25? No. Negative 50 cents plus a quarter, is that negative 25 cents? Yeah, so that's good. One more to check is negative 1. So wherever there was an x, we again plug in our value, which in this case is negative 1. Here's where parentheses are important, because negative 1 squared has to square the sign as well. Okay, so just like we did the last one, what will the denominator be here? Negative 4. What happens when we have a negative divided by a negative? A positive. Positive 1/4. Plus negative 1 over what? 2. Equals 2 divided by, okay, what's negative 1 squared?
1.
Positive 1, good. Minus 9 was negative 8. Okay, so you've already told me these answers. 1/4 we know is 0.25. Negative 1/2 is negative 0.50. We already said that was negative 0.25. This is actually the exact same as the last one, except for reversed order. So, does it work out? Yes, it does. Okay, so we are actually allowed to say that there's no extraneous solutions, and this definitely, both of these are answers. Okay. I'm going to give you a quick stretch break, okay, because it's almost long, so we have to check it. So you have a minute to take a quick stretch break. Right, to stand up and stretch, move around, do it. Okay, one more to do. Yes, the whole thing. Please write it down. Alright, guys, we have 10 minutes left. 10 minutes left. We're on a short day because of assemblies. Please write down. I'll read it for you. Annie? Yes. Oh my goodness, I have to write? Wow, this is school.
This is math.
Yeah, we write.
Yeah, we have to write all this down.
It's not, guys, it's not that hard.
I'm already done.
Please write it. Stop complaining about it.
Flight across.
A flight across the United States takes longer east to west. A flight across the United States takes longer east to west than it does west to east. Assume that winds are constant. There is one like this on your homework, so I recommend writing it down so you have an example to look at. Assume that winds are constant in the eastward direction. When the plane flies westward, the headwind decreases the airplane's speed. What's a headwind?
Wind coming straight at you.
Yeah, wind blowing in your face, going against you.
But it would be the rotation of the earth causing a longer trip, wouldn't it? Not the actual headwind.
That's
Yeah,
a good idea.
that's a deep thought, Styles.
Styles,
Very deep thought.
I'm being serious.
Let's ask him.
That's probably a factor.
When I fly my airliner, I have to account for that.
Okay. We have a pilot in our midst. Alright, when the plane flies eastward, the tailwind increases its speed. The time for a round trip shown at the right, and I'll show you the picture in a sec, is 7 3/4 hours. What's 3/4 in minutes?
45 minutes.
Okay. 7 hours, 45 minutes. If the plane cruises at 480 miles per hour, what is the speed of the wind? Alright, so let me show you the picture really quick.
Wait, how many miles did they travel?
That's what's on the picture. We'll get right back to it. You can finish copying it in just a second. Here's the picture. We're going from Chicago to San Fran. How many miles is it? 1,850. And notice the arrow direction.
Yeah.
Which way are we traveling first? To the west. Okay, so we're just going to add that to our picture. Alright, let's just do a mini picture really quick. We have San Fran and Chicago. Going to San Fran, it's 1,850 miles. Okay, going to San Fran, is that east or west bound? You're heading to San Francisco? That's westbound. So you're starting on the east, you're going west. We're going to be creating a table which will help you solve it, which you'll also need on your homework. Okay? When we are heading westbound, do we have a headwind or a tailwind? Let's see. As soon as when the plane flies westward, the headwind. Okay, decreases the airplane speed because when you have no.
I think. Crushed them right there.
Okay. When you have wind pushing against you, it's going to slow you down. What was our speed? 480. Our speed was 480. That's what you set the plane to, but if you have a headwind, you're going to be decreasing your speed. What mathematical operation decreases? Subtraction. But we don't know the speed of the wind because that's what the question. We're trying to find that. So it's going to be 480 minus x. Right? So we're going to do a chart here. Okay, our direction, 4 columns, direction, distance, rate and time. Okay, so we already said direction, east to west. The distance was how much again? 1,850 miles. What does rate mean?
480 miles per hour.
It's the speed, but we have a headwind, so we're going slower than that. So it's 480 minus the wind pushing at us. Okay, do we know the time it takes to go from Chicago to San Francisco?
No.
What does this time represent?
Round trip.
Round trip. That's the total time. 7 hours and 45 minutes. Total time. What about the other direction? We turn and go back, because it is round trip. West to east. What's the distance?
1850.
It's still the same distance, no matter which direction you're heading, right? It would take you 2 days to drive from Utah to Chicago.
Yeah.
Oh.
In California.
I've been going 100.
Yeah, but we're going from San Francisco to Chicago, which is going to be at least 3 days drive.
Oh.
Yeah. I used to live in Chicago and I used to live in Ohio, and Ohio's further. So to go from Salt Lake to Ohio, it took us 3 days. Which there are stops and stuff, but yeah.
I got shot.
Okay. So, okay. Please, we have 4 minutes. 4 minutes. I told you there's one on your homework like this. Sorry, it's a short day, but there's something I can't do anything about that. Okay, this time we have a tailwind. So tailwind's going to help us speed up. So how do we show speeding up? Plus. Okay? Who's taking physics?
I took it last
Okay,
year.
there's a formula you should know for distance from physics. Distance equals, you guys probably know in physics, velocity times time.
Yes.
So in our case, it's rate times time, because that's speed, velocity is speed. Rate times time. The thing we're missing here is the time. So to get time, we divide by rate. To get time, we divide by rate, which leaves us with distance divided by rate equals time. Okay, so we can set up our time finally. The distance was 1,850 divided by the rate. It's a ratio, or a rational, because it's a fraction. And again, another fraction, 1850 divided by 480 plus x. Okay, so to solve for the wind, we can finally set it up, and then the solving process will be exactly the same as number 1. Okay, if you want round trip, you go to San Francisco and back. What mathematical operation represents and? You go this way and this way. Plus. So we're going to take those 2 fractions and add them. 1850 over 480 minus x plus. Okay, oh wait. You pull out your notes again. Pull out.
480 plus X.
Equals 7 point, I'm going to put 7.5. Isn't that the same as 3/4? 0.75. Okay, so we're going to have to stop here, but to solve for x, it's the same 4 steps we did on number 1. First, factor if needed. Do we need a factor here?
Yes.
No, there's not a trinomial. There's not an x squared. Second, find your lowest common denominator, which would be 480 minus x times 480 plus x, right? Times it on all the numerators. Okay, then distribute and solve, and make sure you check. Okay, your assignment tonight, you have 9 problems. 9 problems isn't that much. I hope you will actually do your homework this time. It begins on page 402. I'm just going to give you a word of warning for the first problem. The first problem, when you solve, it has a quadratic. It's a trinomial. Remember to solve quadratics? This one doesn't come out nicely, so here's your hint for number 1. You have to use the quadratic formula. Number 1, you have to use the quadratic formula to solve it. That's Pythagorean theorem. Negative b
No, I'm not.
That's a quadratic. So as an assembly, guys,